Recording. Okay, 11.6, Kirchhoff's law. So the learning goal is outline the three requirements for a functioning circuit, define and use Kirchhoff's law to solve two simple types of circuits, series and parallel. Solve a circuit consisting of both series and parallel circuits in combination with resistance. Okay, this is a simple circuit. We have batteries. You see, we have a positive and negative end. We have a light bulb. We call it resistance. We have wire. The electron will move from negative to positive, but conveniently we say that the positive charge is the one that is moving from positive to negative, right? And positive has higher potential. This battery provides potential difference across this wire. Like if you put your voltmeter across this 2 point across this battery, you can measure the amount of voltage this battery provide for this circuit. So produce current just conventionally from positive to negative, and positive is higher potential to lower potential. So this is my current. I say it's I. This is the light bulb. Again, if you put your voltmeter across the light bulb, you have to put the voltmeter in parallel. Measure the voltage. That would be the same as the voltage you're measuring across the battery. Why? Because these 2 points, I call it point one, and I call here point one as well. These 2 points, point one and point one, they are the same point. Why? Because this point is just simply connected with a wire without any interruptions. All questions we do, we just assuming that these wires, they don't have resistance. Kind of the resistance is negligible in the wire that we using in our questions, right? So point one and one are the same because there is nothing happening to your electron. Let's say this is a little resistance. So the potential point one and point one here is going to be the same. Also, this point, I call it point two. I call this one point two. These 2 points have the same potential because they are connecting with each other simply with a simple wire, and nothing is on its path, right? It's not interrupting the wire. So point two and point two are the same. That's why the potential difference across the light bulb and battery is the same. So you already know the potential difference is volts, V, current in ammeter, resistance ohm, and power is W. And we put them together, make it circuits. Okay, so this is more practical. If you go to the lab, you will see kind of this kind of setups. So for a circuit, we need to have three characteristics. We need to have a closed circuit with wires. See, these wires are closed. If they are open, the current cannot pass through an open path, right? It need to be connected. A circuit must have an energy source to function. Of course, you need the battery. I believe that's the battery here. V, right? Battery, I call it B. A circuit must have a load to receive energy. So these are, I see that there are different loads here. This is the load. This is light bulbs, we call it load. Electricity turn into light. And here is switches on and off. When the switch is on, means the path is closed. Switch on, closed path. When it is off, is open path. You know, the current, the one of these items, we need to have a closed path, right? The wire need to be really closed. The open path, the electron will not move through open path. So type of circuits, we have a parallel and we have a series circuits. So I believe we have this nice picture. Series circuits, when everything connected one after each other, right? In series. It's light bulb connected to another light bulb and connected to the battery this way. It's back to back. Since there is only one path for electron to flow, it means all of the current in the circuit passes through each load of the circuit. Okay, what that means, electron comes, actually this is a positive charge, right? Conventional current coming from the positive port in and it's passing through the first bulb, then second bulb, then third bulb, and go back to the battery. So the electron is just one path, taking one path and going through all of these light bulbs. That's why this is serious, right? The energy from the battery must be distributed among all of the loads in the circuits. So since the energy, this voltage provided here, we call it total voltage, right? Here, the voltage, if I just call it V, V of the battery or V total, it's equivalent the voltage across the first bulb plus the voltage across the second bulb plus the voltage across third bulb. So V total or V of the battery is V1 plus V2 plus V3. In a series circuit, you add up the voltage and see this addition of all the volts is going to be is the same as the voltage across these 2 points, right? These 2 points is the same as the points on your battery. So that's the law, or you can say that energy is distributed among these bulbs.
Miss, why is V total like V1 plus V2 plus V3 if you set like the voltage is the same?
Voltage is not going to be the same. Remember that if we had a light bulbs, right? Let's call that something like this. And here is voltage. Then the voltage, sorry, just I need to make it like a battery. This is my battery. And voltage across the battery would be the same as the voltage across this light bulb, right? Because these 2 points are the same. These 2 points are the same, right? These two voltage would be the same. But when you have a two light bulb in series, this is this is the light bulb one, and this is another light bulb. This voltage that you have, the the battery provide would be addition of these two, right? Is the same as voltage across both of these bulbs, true? Why is not gonna be, so I call this one V1. Okay, here. I call it V1 and I call this one V2. Okay, why V2 is not the same as V total? See, this one is connected to this one without any disruption, right? It's just a wire. But that end need to pass through this light bulb to get to this, right? So this point, I put it as a star, is not the same as this one. Because if you want to connect them, you have to pass through a load to get there, right? That's why the V total is not going to be the same as V2. Okay? If they want it to the same, so they need to have their ends across them need to be connected without any interruptions. Since the voltage is related to the energy, the voltage provided by battery, we call it V total or V of battery, is equal to V1 plus V2 in series circuit. This plus that is equal to that. It makes sense because this plus that would be from here to here, right? That connected to the battery without any interruptions. Did that make sense, Angelina? You can ask me more question to clarify your
Yeah, so is V1 and V like also not the same?
V1 and V2. It could be the same, depends on resistance. But addition of these two for sure is equal to V. Okay.
Oh, I meant the V and VI, or that says one.
Sorry, V and V1.
Yeah.
Okay. So this ends related to this ends without interruption, but the other end have to pass through the load to get to this, right? So this end's not gonna be the same as this end. That's why they're not gonna be the same. Both ends need to connect with each other without any interruption. So then you can say they have the same voltage. But if at least one of that is not going to that without interruption, so you cannot say this voltage is the same as that, right? Because this point is not the same as this point because you have to pass through a load to get to this point, right? But this point is the same as this point because you don't get anything on the way. Hmm?
Okay, thank you.
You're welcome. If you want me to explain that again, let me know. This is very important and it's really, you can enjoy that after you just confidently understand what's going on. Angelina, 100% good? Or you want me to say it again? Maybe it's helping.
I'm pretty much good, but just one more thing. When you
Mhm.
say V like total, right? Like what does like V total like represent kind of thing?
V total is kind of these two ends, all of the voltage across these 2 points. Maybe just say that V total here, right? So across these 2 points, I want to find the voltage. If I just want to find the voltage across these 2 points, I just add all the voltage on a way, right? So from here to here is V1, V2, V3. I add them up. Or maybe I just make it some color. I take this path to go through V1, V2, V3 and add them up. Or I can go uh, from here to here, right? Which is going to be the V of my battery. So the V of battery is the same as V of total across these 2 points because the battery provide that, right? Is the same as V1 plus V2 plus V3. Again, I'm gonna find the V total is the voltage across these 2 points. I can look at this half of the circle and add them up, or I can just go from this point to this from this path, right? There's two paths. I can go this way, or I can go this way, right? If I go this way, I'm adding all of the voltage here. If I go this way to this point, I have just battery. Okay, it doesn't matter which way you're choosing, but just to show you that addition of all of this voltage is the same as the battery, the voltage of the battery.
Okay, yeah, thank you.
Yeah. Okay, you're welcome. Very good questions. Thank you, Angelina, for asking this good question, clarifying things. I hope that you, if you have any question, just open your mic, ask me question, clarify things. That would be very, very good, and I'm enjoying answering your questions. All right. So series circuits, again, one path. Okay, we did that, right? Yeah. Now, this is the V series. I told you V1, V2, V3. Even if we are connected in the series, the V in series is gonna be V1 plus V2 plus V3. Dot 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 means you could have as many as load as you want, right? And the current passing through each load gonna be the same. I'm gonna go back to this. The current passing through V1, V2, light bulb 1, 2, 3, they are the same because this is just one path, right? It's like a, just imagine there's a river. The river, instead of the river, the water, you have electron. So the current passing through each of this bulb is going to be the same, or the current, or the river. So I1 equal to the I2 is equal to I3. Okay, if you have one path, is the current is going to be the same. Now that's a moment that we could use our understanding of what's happening to solve this kind of problems. As saying solve for all of missing values. What would be the first things you put in? So we have a series, it's obvious. It's light bulb here connected to this one. This is one path, right? They're connected in series, these three light bulbs, and we have a battery here. Uh, what is the first things you can do about that? Do you start with currents or do you start with voltages? That's my question.
Voltage,
Hmm. So good. We could do that. Can you tell me what should I write?
10 equals 2.5 plus 3 plus V2.
Plus, okay,
So
okay,
10
plus
minus
3.
V2 equals, okay, wait, my bad,
Mm-hmm.
5.5.
Yes. And V2 will be 4.5, right? Okay, good. Thank you. How about this currents? What would be my I1? Any suggestions?
Isn't it just 3?
Exactly. Good, because this is serious. All of the current would be the same, right? Easy to put the current. So again, in serious, the current is just one path. The current won't change ever, like a flow of the water. Just have the same water everywhere. Um, so that would be Tria River. And what's your name?
Jacob,
Thank you, Jacob. Excellent. So V total is equal to V1 plus V2 plus V3. Okay, across the light bulbs, the same as the voltage that the battery provides. Thank you. Any question before I move on? No question? We're going to the parallel circuits. Now, what is a parallel circuit? You see, we don't have one path. This is one path, two paths, three paths. These three light bulbs connected in parallel. I'm gonna draw something. So this is the voltage across battery. We call it V total, V total or V battery. And I call the voltage across this light bulb, I call it V1. I call it voltage across this battery V2, this light bulb V2. And here I call this voltage V3. So if this is V total, can anyone tell me What's the relationship between V total and V of each V1? How they related?
They're equal.
Very good. Can you tell me why?
Uh, Honestly, I had it in mind for a second. I already forgot.
Yeah,
Give me a
that's
second to think about it for a sec.
mhm. So think about these points connected to that point. Would be this point the same as this point or not?
Yeah, it's the same wire.
Exactly. There you can connect these 2 points without any interruption. There is no devices or light bulb or crazy things on a path, right? So it's just simply you can connect them with wire. So it means this point and this point has the same potential. Also, this point you can easily connect it to that one without any interruption. They are the same. So two end of this light bulb can be connected with the two end of the battery without any interruption. That's why the voltage across these two are the same. So V total, same as V1. How about the voltage across V2, across the second light bulb? Compare it to the V total or
It would just be V total minus V1.
okay, again, we can analyze the same thing. This point can be connected to this one without an interruption, right? It's just a wire.
Oh, yeah.
Same here. This point you can connect it with this ends without any interruption. So it means these 2 points are the same as the points across the battery, or these 2 points the same as across the first light bulb, that they can be connected without any interruptions. So I can say that V total is equal to V1 equal to V2. How about V3? The voltage across the third light bulb. How does that relate to the rest? Can we say the same thing? This point can be
Yeah, would
connected.
that still be equal?
They're going to be the same. Good. So this point can be connected to this point without any interruptions, just a wire, right? Here, you can connect it with the end of the battery. So these 2 points across the battery is the same as the 2 point across this light bulb. So you can say that they are equal. The voltage across them are equal. Now, very important. Now, how about the current? See, like a water comes. Maybe I just put that in a nicer picture. Do you have a nicer picture actually? Somewhere I don't have. Okay, I'm gonna make it. All right. I'm gonna talk about current. Actually, I'm gonna erase this a little bit so you can see that better. Because this is a nice chart, I guess. See, the current is coming. The current is like an I, right? I call it I. Current coming from the battery. Then some of that will going through the, like it will be diverted. Some of this current going through the first light bulb. Some of that going through the second, and some of that is going through the third. Okay. So you will have the actual current will be divided into the three paths, right? If I want to make that nicer, maybe I can do that like this. This is another light bulb. This is another light bulb, light, right? Okay. This is my battery. Uh, so the current comes, some of that going through the the first light bulb, I call it I1. Some of that will go through the second light bulb as I2, and some of that will go through The third light bulb is going to be I3. All right, so I total then is equal to I1 plus I2 plus I3. You can imagine that a flow of water comes and you have a 3 opening path. Some of that going through this, and this. This is the point that your I will be distributed along these 3 paths. So I total the incoming is the equal to addition of outgoing. When we do the Kirchhoff law, you will see that when we get to the nodes, you apply the laws. So the incoming is equal to outgoing. See, this is coming to this point is I. Should be equal to outgoing. See that these 3 are going out of the point. So I1, I2, and I3, you add them. Outgoings is equal to incoming. Okay? So these are parallel circuits. All of the currents in a circuit must be distributed through each load of the circuit. We did say that the energy from battery must be entirely used up among us all of the loads. So just V1, V2, V3. Same is for, well, this should be parallel. Parallel. That's some mistake here. Oopsie. Okay, what's that? All right, here is again, we want to see this tree of this uh, are connected in parallel. How do I know parallel? Because this point is the same as this point, is the same as this point, is the same as this point, right? They're connected entirely without interruption. Also, this point is the same as this point, is the same as this point, the same as this point. Again, they all are connected without any interruption. Then I can say the voltage across the battery is the same as the voltage across the first load, voltage across the second load, same as the voltage across the third load. So this is easily, I can say all of that is 5, 5, 5. So since this is incoming, right? This is I coming to this point. The current passing through the first load is I1. Current passing through the second one is I2. Current passing through the third one is I3. Since these 3 points are the same point, it's like these 4 points are the same point. It's just saying the incoming into the point, and these 3 are outgoing, right? So I total or incoming, call it I total, is equal to outgoing, add them to each other. So these 3 are out of the point, and this one is just into the point, right? So incoming is equal to addition of outgoings. So the total I don't have, I1 is 1.5 plus I2 is 2.5, I3 is 1. It's going to be 5 amp. I just fill that here. Any question? Very important. If you don't understand it, you need to open your mic and talk to me. No question? Okay. So how about the resistance? We did talk about the voltage currents. Now we want to find the total resistance in the circuit. If the resistance connecting to each other in series, this is how we add them. I'm just going to put that here in. So again, this is my battery. This is R1. Here is R2. Here is R3. R1, R2, R3. Since they are connected in series, the total resistance of the circuit is equal to R1 plus R2 plus R3. I can prove that for you. You know that in series circuit, V total or V of the battery is equal to V1 plus V2 plus V3. We had that in series, right? And V is equal to Ri, right? So here, instead of V total, I can write R total multiplied by I. V1, I can write it as R1 multiplied by I plus R2 multiplied by I plus R3 multiplied by I. Why this is the same I everywhere? Why I don't say I total I1, I2, I3? Because in a series circuit I1, I total is the same as I1, is the same as I2, and I3, right? We said that this is just one path, and I gonna be the same. That's why I just put it everywhere the same. Now you can divide each term by I, and then you will have R total is R1 plus R2 plus R3, okay? This is the proof of that. Now we have this, and we want to find the total R of the system. They are in series, so R total simply is 2 plus 5 is 7 ohm. Same thing, they are in series. R total is 2 plus 5 plus 7 is 14. Okay, in series. Okay, we have 2 minutes. I don't think it's a wise thing that I just continue with that. When we come back from the break, I want to do the resistance in the parallel circuits. We find some resistance in the circuit, and then we do these lovely examples together. I work on some extra questions solving for the circuits.